Welcome. So we continue from where we ended. Question B8. Ammonia is manufactured industrially in the Harbert process. State the chemical formula for ammonia. Is ammonia an element, compound, or a mixture? Give a reason for your answer. Write a balanced chemical equation that takes place during the Harbert process. Then state any two conditions necessary for to maximize the yield of ammonia during the Harbert process. So we are looking at the issue of nonmetals, where we will discuss nitrogen and hydrogen and a molecule of ammonia. So let's look at the whole concept of ammonia, starting from the preparation in the laboratory to the industrial preparation. So ammonia, we know that ammonia, the physical state, it is a gas. Then the chemical formula for ammonia, it is NH3. Now this ammonia can be prepared in the laboratory or in the industry. So preparation of ammonia in the laboratory. So the requirement which we look at, so the reagent, we have ammonium salts, okay, e.g. we can get ammonium chloride, ammonium sulfate. We also have ammonium nitrate. So these are the ammonium salts. Then the other one, we need to look at calcium hydroxide, which is also called slacked lime. So calcium hydroxide is also the reagent. So once we react ammonium salts, you can choose from the salts given, and calcium hydroxide, we are forming ammonia, water, and salt. So in the lab, we use the downward displacement method. So let me bring up the diagram. Okay. So the downward displacement method, you're looking at this diagram. First, we talk about this one. So if you look at this diagram, specifically downward displacement, we have this one. So we have three, and each displacement has got its properties for it to be used. So we have displacement of water, we have downward delivery and upward delivery. So here we are saying we use the displacement of water, this diagram. What do we consider? So the properties of gases which can be used for this one. Number one, the gas must be insoluble in water or slightly soluble in water, in the sense that the gas which will be produced must pass through water and then it is being collected here where there is gas jar. So if the gas is soluble here, meaning that it cannot come out because it is soluble. So no wonder we need a gas which is soluble in water, which cannot dissolve in water, or slightly to dissolve in water, but it is able to penetrate and reach this side. Then examples of gases, we have carbon dioxide, oxygen, and hydrogen. So hydrogen, oxygen, and carbon dioxide can be collected over displacement of water. Then the downward delivery, the property of gases, number one, it must be denser than air. So if you say the gas is denser than air, for example, we have chlorine here. So here there is already air particles or air molecules. So the gas which is coming now inside here, if it is less denser than air, it will not replace this air which is already inside. So the gas must be denser such that that gas is able to replace this one by going downward. Hence, it is called downward delivery. So apart from chlorine gas, we also have hydrogen chloride gas, which is hydrochloric gas. Then the last one, we have upward delivery. So the downward is the opposite of the upward. So the properties will be also the opposite in the opposite side. So if downward delivery is the gases must have denser air, then the upward, it must be less denser than air, so that the air now can be replaced. If we have air particles or air molecules here, then as the gas is coming here, since the gas is less denser than air, the gas will occupy this area. So once the gas occupy this area, then the air which was here will go downward. Hence we say upward delivery, because the gas which is being collected is moving upward and displace air which will come downward. So example, we have ammonia. So ammonia gas in the laboratory, it is collected by downward delivery. The reason is because ammonia is less denser than air. So here under preparation, we are saying it is collected by upward delivery. Reason, we'll say because it is less denser than air. So that's about ammonia. Now, since now we know that ammonia gas can be collected by this one, then we can look at the equation. The equation, how we can produce ammonia in the laboratory. Then we talk about the equation, how we can produce ammonia under industrial. So from here, we'll say we'll get one sort. So if we say calcium hydroxide plus ammonium, let's say chloride, we are going to produce, since calcium is more reactive than this, we're going to get calcium chloride plus water plus ammonia. So that's the equation. So to balance the equation, I'm going to put 2 here. We can also put 2. If we balance that one, what are we getting? So nitrogen, then you can put, so we have here, we can put 2 there. Then we can also put 2 here. We have balanced the nitrogen. So nitrogen 2, nitrogen 2, nitrogen 2 there. All right, so this is the equation which we can produce under the production of ammonia in the laboratory. let's look at the setup of the experiment, which will help us to understand now how it is being set. Okay, so if you look at the setup of the same where okay, so we have this diagram. So let's look at this diagram now. So we have the mix of calcium hydroxide here and ammonium chloride. Then we need to eat the mixture. So you apply it. So this is the mixture of calcium hydroxide in ammonium chloride. Then from there you find that from there we will find that we have the mixture. Then this mixture, it is coming downward like this. So if you look at the diagram now, okay, all right, so this part, it is slightly tilted, meaning that here during the reaction there are three products. There is ammonia, there is water, there is also calcium chloride. So if this one is not tilted, the water which is being produced will go back in the same reaction chamber. Once the water goes back in the reaction chamber, that water can cause explosion of the reacting chamber. As a result, you find that the reaction will be dangerous. Hence, the tube must be tilted to allow all the water which is being produced to come out without going back in the reacting chamber. Then here, the gas will come down here. Then after the gas comes here, then since the gas is less denser than air, the gas will start now moving upwards. So as the gas is moving upward here, you're going to find that it will pass through what you call the calcium oxide. This calcium oxide is called the drying agent because there is moisture. As the gas is being produced, which is ammonia, there is also water. So the gas comes with moisture. So that moisture must be removed before the gas is collected. This is the reason why the gas must be passed through the calcium oxide as the drying agent. If they don't use calcium oxide, they can also use sodium hydroxide as a drying agent. We don't use sulfuric acid here. Then here are going to collect ammonia gas as the red moist litmus paper will indicate, because ammonia is a base. So that is about the diagram which depicts how ammonia is being collected. All right, so now from here, let us look at another process by which ammonia gas can be collected. So that was in the laboratory. Then we are going to focus now on how ammonia gas can be collected in the industry. So from here, we'll look at the Harbert process. So the Harbert, sometimes we call it as Bosky process. These are the names of the people who came up with this process. Okay, so in the Harbert process, this is the industrial. This is the industrial preparation. Okay, so we use the reagents. The reagents, we have nitrogen, which is collected from methane, and what we call steam reforming. We get methane. Then also have hydrogen. No, nitrogen is the one which is collected from air. Let me do this. Nitrogen is collected from air. Then hydrogen from steam reforming. Of methane. Okay. So here, during this process, there are conditions which are there. So conditions, number one, we need temperature. We need pressure. We also need a catalyst. So catalyst is ion. So then we'll say the process which takes place, the first thing in the Harbert process, you're going to discover that we have the first situation where we have the first tank. We also have the second tank. So this one is for nitrogen. This one is for hydrogen. Now these two tanks, they go into a third tank, which is called a compressor. So the compressor as nitrogen and hydrogen, are coming here. So here you're going to find there'll be nitrogen and hydrogen. So the essence of compressor is to make sure that it compresses these two gases and at the same time removing the impurities. So from the compressor, then the two gases will move from this chamber and goes into what you call a converter, a round chamber, a converter. So this converter now, it has beds of ion. So these beds of ion act as a catalyst. So ion act as a catalyst here. So when these gases are coming, so we have nitrogen and also have hydrogen. When they come here, so as we have nitrogen and hydrogen here, during the reaction, you find that about 10 to 20% of ammonia will be produced. So 10 to 20% of ammonia will be produced here. So here we are having nitrogen, hydrogen, and ammonia gas. So these gases now, okay. So we have nitrogen, hydrogen, and ammonia. So these gases from here, they will come into this tank. So this tank now, we are going to collect ammonia gas. Then from here, since let's say 80% of nitrogen and hydrogen is not converted to ammonia, then these will go back again here. Okay, so here we have nitrogen and hydrogen. So this nitrogen and hydrogen here, it goes back because it has failed to react to form ammonia. Then from here, ammonia gas now will be stored. So storage tank. So storage tank of ammonia. So ammonia now is stored here under pressure. Then again, this nitrogen and hydrogen will come back into this system. Again, it will go back. Again, 10% to 20% of gas, which is ammonia, will be collected. Again, the remaining percentage will go like that, with a probability that these two gases, again, after passing through a catalyst, will form ammonia. So this is what happens during the Haber process. So this ammonia which is being produced. So this ammonia now, it is now a compound. So ammonia compound. The reason why ammonia is a compound, it is because it cannot be, ammonia gas cannot be separated into nitrogen and hydrogen by physical means. So ammonia is a compound because it cannot be separated by physical means into nitrogen and hydrogen. Or in short, we can say because it has been combined chemically, hence it is called a compound. So that is how ammonia is being produced. Now the ratio of the reaction, you'll find that the equation will be nitrogen 2 plus hydrogen. We are going to use the arrow which is reversible. So reversible arrow means that this reversible arrow means the reaction can ammonia gas can go back to nitrogen and hydrogen can form ammonia. So we use a reversible arrows. Then we need to balance this equation. So we have gas. So these are gases. So since the ratio is into 1 to 3, so I have three atoms of hydrogen, we have 2 atoms of hydrogen, then we have 1 atom of nitrogen. So for us to balance this one, what can we do? We are going to use the same concept of balancing the equation, which we said whenever you're balancing the equation, we need to look at the number of atoms which are taking place in the reaction from both the reactant part and the product part. So if you look at the product part, you find the nitrogen is 2. While here the nitrogen is 1. So I'm going to use these 2 and put it here. So now since nitrogen has balanced, nitrogen 2, nitrogen 2, then these two multiply everything. So meaning that 2 times 3, you're going to get 6 atoms of hydrogen. Then here we have 2. So I'm going to get this 3, which is here, and put it here. So 3 times 2, it is 6. 2 times 3, it is 6. So the equation is balanced. Therefore, the ratio of the reactant, the ratio is 1 to 3. 1 here, 3 here. That is the ratio. Then from there, we can look at I've talked about the conditions already. So what is remaining, we can look at the uses of ammonia and the physical properties of ammonia. So let's look at maybe 3 uses of ammonia. So uses of ammonia. Number 1, we can say ammonia, it is used as a cleaning agent. So used as a cleaning agent. Then the other one, ammonia is used in the manufacture of explosives. So used in the manufacture of explosives. Then the other one, we say ammonia can be used in the manufacture of plastics and glue, or ammonia is used in the manufacture of nitric acid. Also, ammonia can be used to produce fertilizers. So we'll talk about this next time. So used in the manufacture of fertilizers. So those are some of the uses. Then the physical properties of ammonia, we'll talk about maybe 3 physical properties of ammonia. Then we answer the questions now from the question. So the physical properties. So when we talk about physical properties and the chemical properties, these are 2 different things. Physical properties, we're looking at the things which we can observe or see, or touch or sense or smell during the testing or the handling of these. Then when we talk about the chemical properties, we're looking at how ammonia can react and the products that can be formed from there. So the physical properties of ammonia, number 1, since we said ammonia is a base, it means that it can turn a damp red litmus paper blue. Then the other physical property, it burns in pure oxygen with yellow flame or brown flame. So these are chemical properties I'm talking about. The physical property we're talking about, it is less denser than air. Okay, chemical properties, we'll talk about them later on. The physical properties, we are saying it is less denser than air, the one we talked about earlier. It is less denser than air. Then the other one, it is very soluble in water. It is soluble in water. Then it is colorless gas. A common one, it is a colorless gas with a pungent smell or a choking smell. So these are physical properties of ammonia. Then the chemical properties. So the chemical properties, as I started earlier on, it turns a red litmus, paper, blue. Then it burns in pure oxygen. It burns in pure oxygen. To give a yellow or brown flame. Alright, then it dissolves in water to form ammonium hydroxide. It dissolves in water to give or to produce ammonia ammonium hydroxide. Okay, so that is the summary of preparation of ammonia, both in the laboratory as well as in the industrial. Industrial, talk about the Harbert process. Then in the laboratory, talk about using of upward displacement in the reactants, which sort. So let's look at the paper which we had. Now we can answer it very fast. So it was question 8. All right, so state the chemical formula for ammonia. So the chemical formula for ammonia, now we said it is NH3. Then is ammonia an element, compound, or a mixture? We said ammonia is a compound. Reason we said it cannot be separated by physical means into hydrogen and nitrogen, or simply because ammonia, the reaction of nitrogen and hydrogen is chemically, then write a balanced chemical equation that takes place during the Harbert process. So they have specified Harbert process. So just say nitrogen plus hydrogen, then we put the double arrow to form ammonia. So it's a gas, it's a gas, it's a gas. Then we said we'll put 3 here. We get this 3, we put it here. We get these 2, we put it here. So state any 2 conditions necessary to minimize, to maximize. To maximize means to increase the production. So we talked about temperature, which is from 100 degrees Celsius to 500 degrees Celsius. Then a simple one can get a catalyst, which is ion. So that is how the question was demanding. So thank you for watching. Watch for another video.